Hi everyone, my name is Reed Proctor and I've been teaching pharmacy calculations for over 10 years. And in the following videos, we're going to be looking at alligation medial. Well, what is alligation medial? Well, you can think about it this way. We can think about, let's say you have a 25% solution of, let's say, maybe alcohol. And you also have maybe another 15% solution of alcohol. And let's say you're going to combine these two solutions. And the question is, well, what would the percent concentration of the resulting product be? And that's really what alligation medial has to do with. And the following examples we're going to cover will be showing you the method by which you can calculate that resulting percent strength. All right, so let's take a look. Okay, the problem says, what is the percentage strength, volume to volume of alcohol in a mixture of 2,000 milliliters of 25% alcohol and 1,000 milliliters of 15% volume to volume alcohol? Assume no contraction of volume after mixing. Round the answer to the 10th place. Okay, so for this problem, we have the 2,000 milliliter solution that has a 25% concentration of alcohol. We have the 1,000 milliliter solution with the 15% concentration of alcohol. And the two will be combined, and we need to determine the final percent concentration. We will need to determine, well, how much alcohol is in the 2,000 milliliter solution, how much alcohol is in the 1,000 milliliter alcohol solution, and that'll help us determine the final concentration of the final mixture. Okay, so 25% concentration, so that's 25 milliliters per 100 milliliters is another way to express that. Well, if there's 25 milliliters for every 100 milliliters, we need to determine, well, how much would it be for 2,000 milliliters? We'll put in X here, and we'll solve, we'll go and do our basic algebra, solve for X. We should get 500 milliliters of alcohol in the 2,000 milliliter solution. All right, we'll do the same thing for the 1,000 milliliter solution that has a 15% concentration of alcohol. So that's going to be 15 milliliters for every 100 milliliters. Another way to express that. We'll say equals, and we need to know, well, how much is it out of a total of 1,000 milliliters? Okay, we'll solve for X here. We solve for X and we get up 150 milliliters. So what does that mean? Within this 1,000 milliliter solution, 150 milliliters of that, you can consider that to be the pure alcohol. In this 2,000 milliliter solution, 500 milliliters of that 2,000 milliliters is alcohol. Okay, so now it'll be helpful if we can add these together. We'll find the sum. 500 plus 150 milliliters will end up with 650 milliliters. That's 650 milliliters of alcohol that we will have in the final mixture. But then what's the total quantity of the mixture going to be? Well, we have the 2,000 milliliters and the 1,000 milliliters. We're going to add these together. We'll get 3,000 milliliters. And we determine we have 650 milliliters of alcohol. Okay. Now we have enough information to determine the percent concentration. And at this point, volume to volume concentration, milliliters over milliliters, these are the units we need to determine our percent concentration. So at this point, we have a fraction. We need to convert it to a percentage. You could set up a proportion equals X over 100. Or you can just simply remember the algorithm. Numerator divided by denominator times 100 gives you your percentage. So if I go 650 divided by 3,000, we want to round that to the 10th place, you would get 21.7%. So that'd be the concentration of alcohol in the final solution.